Okay, it's time to get started with Planetarium Live, Episode 10. It's been a couple weeks since we've done a live stream, but today we're going to talk a little bit about comet NEOWISE and seeing it in the sky, and kind of where it is along its journey. We're also going to talk about some of the things that you can see in the night sky tonight, things that I actually imaged last week during a somewhat impromptu trip up north to a nice dark sky site where I got to use my telescope for, that once per year kind of thing. And then finally, of course, we're going to be playing around in Space Engine a little bit and exploring some of these objects in the night sky and seeing what's out there. So let's get started with Comet NEOWISE. Now if we take a look at, this is one of my favorite sites for viewing the comet. One of the nice things about this is it gives you a bit of a trajectory of the comet. You can see kind of where it is in its orbit. You see that comets really have this habit of going super, super close to the sun and then flying way on out. And you can see Comet NEOWISE is actually still pretty close to Earth. Let's see if we can get a bit better view there. There you go. So Earth is here, the comet is there. Closest approach was not that long ago, July 23rd, as you can see right about here. Although it also wasn't as bright as it was when it was very close to the sun. And so one other thing we're going to take a look at is this little chart here. This is the brightness curve, where it gets brighter and brighter and brighter. Its maximum, and now we're slowly working its way dimmer and dimmer and dimmer as it falls away from the sun. I did manage to get a good look at this comet a couple of times and pulled out a couple images. This is a picture of the comet through my pretty big 8-inch telescope, very close up, and it's true color as well, so you can see the bright green of the what we call the coma, and some of the dusty tail that's starting to come off of it. If we could zoom out a whole bunch, you would see a lot more of this comet, a lot more of the tail, and a lot more interesting things to look at with it. And so I actually want to bring it up in Space Engine so we can go take a look at the comet and see what it might look like. Of course, with Space Engine, we often start at Earth. Looks like we have a friendly viewer in chat. Thanks for coming around to see what we got. Please let me know if there's anything that you want to look at. So let's go to Comet NEOWISE. I think we just searched NEOWISE. There it is. And we're going to do a nice travel out to the comet in about 10 seconds. You can see it's still doesn't take long to get there. It's pretty close. And this is this is what a comet looks like up close. Now, it's important to note that with NEOWISE, we don't know exactly what it looks like, but we do know that comets are typically these big, dirty snowballs. Based on how big the coma and the tail of the comet are, we can kind of get an estimate of its size. We think it's around 4 to 5 kilometers wide, which is pretty big, although pretty common for a comet. Most comets are kind of these dirty snowballs, like the snow that you find when you pick up some of that slush and stuff in March or April. And so that's what NEOWISE looks like. If we zoom out, though, you can see that the material coming off of this comet, the dust, the gas, the ice, as we start to fly further and further away, we're going to start to see the shape of the comet take hold. But you have to go pretty far. The coma, this big bubble around the comet, that's that green in the photo I showed, this green part here. The coma is pretty huge. And as we zoom out even further, and a little bit faster, now you can start to see how big the coma really is. And take a look at the two tails. The ion tail, which always points away from the sun. So if we kind of fly around here, you'll see the sun, and there's that blue ion tail falling away. And the dust tail, which actually tends to drift behind the direction the comet's traveling. So the comet's actually going kind of down in this direction, down and to the right. And the dust tail is being blown away by the sun, but the comet is also flying away from the sun, and so its tail is getting pushed a little bit. But it is very bright in the sky. And just to give you a sense of kind of where it is, we can bring up the orbits of the solar system here. There's the comet right there. And if we bring up some labels, you can see Earth is right there. So the comet is still pretty close to Earth, but you can see it's above the solar system and kind of flying back out into space. So there we go. So that is Comet NEOWISE. Now today was a really interesting day, if you were up early, to look at Mars, because the newest Mars rover just launched and actually is on its way to the red planet right now. So we're going to go to Mars and take a closer look. The rover's called Perseverance, and it's very similar to the Curiosity rover, which is already on Mars. We're actually going to fly in and take a look at Curiosity because I actually do have a model of the Curiosity rover loaded in Space Engine, so we can actually get a chance to see what the rover looks like. And Perseverance, the new rover that just launched this morning at about 10 to 8 Eastern Time, that rover is about the same size as Curiosity, but it has a lot of new instruments that we're going to take a closer look at. So why don't we go on in? And actually, I think the first thing I'm going to do is try and show you where the landing site is. We can't see it because it appears to be on the night side right now. So what we're going to do is we're just going to make a quick change. Turn up the ambient lighting so we can kind of see the dark side of Mars. And the landing site for this new rover is called Jezero Crater, which is actually right about here. I usually find it by this mark here, but this big, you can kind of see a big circle right here. That's called Isidis Planitia, which is it used to be a giant impact crater. And so it's a low point in Mars's relief there. And the Jezero Crater is really, really close to us now. It's this one here. It's kind of hard to see. I'm going to brighten it up a little bit. That doesn't help too much, but the resolution's pretty low as well. And actually, I think we can help it out if we just turn off clouds and the atmosphere. Anyway, that's Jezero Crater right there. And this is where that rover is heading on Mars to do some really cool stuff. So let's take a look. We can find Curiosity. There it is, Curiosity rover. Now this might be a little hairy because I bet Curiosity is on the far side of Mars. And so if we go to, so we're going to go and kind of clip on the edge of Mars right now, but that's okay. Maybe I'll go back to the comet and let you look at this image while we travel to the rover. Oh, hey Jen, glad you're here and watching. It's my biggest and one of my few fans. I'm so glad that you keep tuning in to watch all the crazy stuff I do. I do appreciate it. And as always, I'm happy to show you anything that you're particularly interested in or that Lucas is particularly interested in, even if that means going back to the moon every single time. I'm okay with that. And now that I've said the word moon, I bet he's excited for that. That's if he's watching with you. So yes, this image I actually took this past weekend of the comet with my 8-inch telescope in a really dark sky. And so this is true color. It's really amazing that the coma, that core of the comet, is bright green. So it looks quite nice. But here we are now on the surface of Mars, and this is the Curiosity rover. So this is the rover that's been on Mars since about 2012. And it's in this place called the Gale Crater. So I'm going to zoom out so you can see the Gale Crater. There's this giant kind of hole. You can see the mountain. This is called Mount Sharp. It's a big mountain behind it. And the rover's slowly, steadily making its way up this mountain to take rock samples and do all kinds of fun things. But this is the Gale Crater. And a long time ago, this crater used to have water in it. Well, Jezero Crater is one of those places where it actually used to be a giant lake. And Jezero has a channel of a river flowing inward and a river flowing outward. And so this is interesting because if there's water flowing into something, it means there's sediment, and sediment in clay can hold organic material. And so the idea is that, well, if we, that's a bit weird there. The idea is that if we go to Jezero and we look at the sediments there, maybe there are actually organic molecules there. Maybe there is a bit of life left over, or at least some signatures of ancient life. So if there was life on Mars, this is the best place to find it. And so we're sending a rover there that looks a lot like Curiosity. The rover's name is Perseverance, and it's got a lot of the similar pieces to it. Question from Jen in the chat. Ryan, I'm definitely not up to date. Why are we sending another rover to Mars? The rovers are part of a really big kind of 30, 40 year process in sending people to Mars. In order to send people to Mars, we have to do basically as much science as we can to understand what are we going to do when we get there. One of the biggest things is finding water on Mars, and the previous rovers have done that. But like I said, the last rover was Curiosity that landed in 2012. And so it also takes, a year to get to Mars, and almost a year, about 7 or 8 months. And so that means that currently on Mars, we have technology from, 2011, probably older than that, because you have to develop all of this technology for years and years and years. So it's very likely that the rover on Mars, the Curiosity rover, this guy right here that we're looking at, is technology based on, the best in 2005. And so now, the new rover called Perseverance has maybe 2015 technology, but better tech. And because we've learned things from the Curiosity rover, like, whoops, too close, like drilling into rocks and seeing what they're made of, and learning about sources of water on Mars, flowing water. We have orbital spacecraft looking at Mars from above. If we go back, they make maps like this. Like, we wouldn't have this map if it wasn't for the orbiters. All of this gives new goals for the next rover to do, and kind of infers what kind of technology we put on that rover, what kind of instruments. So this new rover is going to be able to dig deeper. It's going to be able to search for potential life. It's going to look for water and sources of water on Mars. And it's actually going to test something really, really neat. It's going to test an instrument that actually takes the atmosphere of Mars, the air around Mars, which is mostly carbon dioxide, and converts it to oxygen. So the idea is that if we eventually send humans to Mars, we're going to need to learn how to make oxygen out of Mars's carbon dioxide atmosphere. And so that's part of the things that it's testing. The rover Perseverance, this mission, Mars 2020, is also testing a helicopter, which is kind of a cool thing. It's sending this helicopter to fly on Mars and see if it actually works. If it works, future rovers will have a helicopter that can fly up into the air and take pictures, look for interesting places to study, and even do a lot of things that humans will find very helpful, like seeking out some targets a little bit further away, mapping certain areas, that kind of thing. Jen asks, are we sending rovers elsewhere? Technically, yes, we do send rovers elsewhere, but mostly like the moon. Rovers have to be able to withstand the temperatures, the pressures. We would never send a rover to a place like Venus, even though landers have been there, because Venus is about 400 degrees. It's really, really hot and really dangerous, rains acid, all those fun things. And so Venus isn't a very good target for a rover because it just can't last a long time. Places that are farther away, moons of Jupiter, Europa, Enceladus, places where there might be life, those are great targets, but they're so far away that it's a lot harder to get something to land there. It takes, 4 years to get to Jupiter, and once you've gone through that 4 years, that technology still has to be able to land, and if it fails, you've wasted 4 years and several $100 million. So Mars is kind of the ideal target in that it's pretty tame in terms of environment, it's not super dangerous, and it's very close, and it's a really interesting place to look for life. So it kind of checks all the boxes. And so hopefully in the future we'll be sending rovers to places other than the moon and Mars. But it takes a lot of money and time, and you also need a lot of reason, right? If we can do this kind of science with something orbiting the planet or the moon or the place that we want to go, then that's a lot cheaper. So we tend to do that. Oh, Jen, you want to know if I would move to Mars if given the opportunity? Well, unfortunately, there's no colonies on Mars yet, so it wouldn't be a good place to live or breathe. Mars is a lot like a desert here on Earth, like in Chile. So although I probably wouldn't go to Mars if given the opportunity, I would love to go into space and just experience the weightlessness, see the Earth from up in the sky, up on high. But I still like Earth quite a bit. And so maybe someday, if Mars does end up colonized and there's lots of people there and there's lots of infrastructure there to support those people and keep them going, maybe then I would go and be kind of a Wild West pioneer, except the next frontier, I guess. So that's a good question. But that's kind of what's going on with Mars. And so I'm happy to answer any other questions about that. The rover it just launched this morning, but it's not going to be there until February of next year. So I wouldn't worry about it for too much right yet, but you'll hear a lot about it starting next year. Now at this point, I ended up taking a lot of images when I was out doing some observing recently. And one of them is this lovely picture. I mean, I'm not a great astrophotographer, but I have a lot of fun doing it. This is a picture I posted on my Instagram. It's called the Trifid Nebula. So this is a giant nebula that's up in the sky, not super far from Earth, but in the Milky Way galaxy. It's a place where stars are being born. And so I actually wanted to take some of these pictures that I've taken and actually go and visit them in Space Engine. And so the first place we're going is the Trifid Nebula. Trifid, there it is. Oh, we're going straight there. I should have actually just centered it first, but we're going to go in close. As you can see, we're heading in through the plane of the galaxy. That's kind of what it looks like. I'm actually going to go back to Earth for a sec, so it'll make a little bit more sense. We're going to go to Earth and take a look at the Trifid in kind of the telescope that we have here in Space Engine. Okay, so what did I turn off? That Earth has no water. Did I turn off water? I did turn off. No. Oh, right. I know what happened. I've got the ambient lighting is way too high. So there we go. That's a bit better for Earth. So we're going to look at the Trifid. And we're just going to center on it. So it's over here. It's in the Milky Way. And we're going to zoom in and see if we can take a look at it. I think we can just... So I guess that's the model of it that Space Engine has, but it's basically a couple of regions of gas and dust glowing at different colors. Forming stars. This dark dust is birthing new stars that when they're born, they start to glow and shine on this clump. So that's not bad considering it's a simulation, but so let's actually fly there now. Let's go see what it looks like up close. Plus it's always fun kind of just flying through the galaxy, nice and softly. Especially when there's some nice kind of calming music in the background, which hopefully we can hear this time. I can always turn it up or down if it's too quiet or too loud. I feel like my voice is pretty raspy today. I've actually spent most of today recording and preparing a video about the Mars mission. So my voice is kind of shot because I've just been recording audio again and again. So here's the Trifid Nebula, and like a typical nebula, it's made of gas and dust. There are some stars that are, I guess, in it or behind it. We can't really see many stars in it right now. But it is this beautiful glowing, these clumps of dust can form new stars. And when those stars are born, their light breaks apart all the little atoms in the cloud. And causes it to glow. And that glow is actually bright enough to see from Earth. So this particular image was actually about 3 minutes of exposure time. If you look at this picture in a telescope or through a telescope, you see a lot of the stars, but you don't really see the glowing gas, the red and the green, blue kind of colors. You can kind of see them a little bit, but not really at all. You need to take a picture in order to see it. But the reason I like this image so much is that it fits really nicely in my telescope. And it doesn't take a lot of imaging to capture it. The problem is, though, is that when you're trying to take a long exposure of something in space from Earth, the Earth is turning. And the more you zoom in, the more you notice the movement of the Earth. And so you kind of get to the point where when you're trying to take a picture of something and it's slowly but noticeably moving. Oops. Oh, I did it. And so you'd be taking the picture, but the object is moving out of the frame. And so you kind of get these stars causing streaks. And you kind of see that a little bit in this image as well. But that's the Trifid Nebula. So let's fly back out. Where did I go to get this image? I was up on Manitoulin Island, which is a place that I used to go when I was a kid. And it's close to, sort of close to Sudbury, if you know where Sudbury is. But one of the nice things about Manitoulin is that it's about a 6-hour drive, and so it's far enough away that not a lot of people settle there. There's not a lot of cities or even towns, and it's in kind of surrounded by Lake Huron because it's an island. So one of the nice things about it is that there's very little light pollution. And so darker skies mean that you can often get pictures like this in a lot less time than you would trying to take the same picture in a bright, light-polluted sky. So if I was in the city and I tried to take a picture like this, I could get an image just like this one, but it would probably take me twice as much exposure time, twice as much time with the camera in order to capture the same thing, and there'd probably be it'd be a little bit more difficult. So dark skies are really nice for that. It's a lot easier to capture images. It's a lot easier to capture nice images, and it's also really beautiful just to be out there and look up and see stars all around from horizon to horizon with no other lights. And so that's a place that I always go to. Lucas thinks it's a moon. Amazing. Well, you know what, Lucas? I'm going to go to the moon just for you, my friend. Because the moon was out when I was there. And it looked really, really nice. It was a thin crescent moon. Really beautiful place to look at. And it looked great through a telescope, too. The moon was one of the few things I didn't take a picture of, but we saw this nice thin crescent. So let's go fly. Let's go fly in close to the moon. Let's go nice and slow. We don't need to hurry up too much. Whoa. I don't want to make anybody dizzy with this, but we're going to fly right over the moon. This line between day and night on the moon is called the Terminator. What a great name, right? Well, the Terminator is great, and when you look at the moon through a telescope or even binoculars at night, the best time to look at the moon is not when it's full, but when it's half full or a quarter or, third quarter. Because you see this Terminator line going across the face of the moon, and what it does is it creates shadows along all these little craters, and that makes them look deep. You can actually get some depth to it, so you almost get this 3D view of the moon where you can see that some of these craters are really, really deep, and some are shallow, and some are, and they're all dotted around the different parts of the moon. So the full moon, although it's nice and bright and you can see a lot of the features, sometimes the best time to view the moon is when it's a thin crescent. You'll see a lot more and actually enjoy a lot more of it. So let's go and explore some of the moon. You know what? Let's go land in a crater. That sounds kind of fun. This is a nice looking one here. One of the cool things about craters, especially really big ones like this one, this is probably, a few 100 kilometers across, is that if you imagine splashing a rock into a flat pool of water, drop a rock into a big flat pool of water. I love it, Jen. He's hopping up and down going, moon, moon, moon. That's amazing. Honestly, to make this kid happy makes me really happy. Because just, I love talking to people about space and sharing stuff. And it's all about getting people excited, right? So thank you for that. So craters like this, if you ever were to drop a rock in a flat pool of water, you get a little bit of splashback. And that's kind of what's happening here. When a giant rock smashes into the moon, it liquefies the rock and splashes back a little bit. And then the rock cools and you end up with this tiny little mountain inside the middle of a crater. So we're inside a giant crater, and there's other craters within this crater, which means they happened after this big rock collided. But we're going to go down and see that this is actually a giant mountain right smack in the middle of this big crater on the moon. And there you go. It almost doesn't look like we're in a crater now, but there is a mountain here on our moon. So let's go in a little closer. At this point, the graphics are a little bit weak because we don't have perfect maps of the moon, but we have seen what the moon looks like. So let's go on top of this mountain on the moon and imagine that we're an astronaut, landed on the moon, living there, and we stand on top of this big mountain in the center of a crater that formed several billion years ago. Let's go right to the top and smack down in the dust. There we go. We are on the surface of the moon, on this crater, looking up at the night sky. There's no air on the moon, and so we can always see stars, even in the daytime, even when the sun is up. Speaking of the sun, where is it? There it is. Whoa. So the sun is up in the sky and we can still see all the stars, but we look out over the moon from this mountain and we can see just craters, hills, mountains in every direction. It's a little bit bright, so I'm going to dim it down a little bit so we have a bit better of a view. And if we could fly up a little bit off this crater, we can see that we're flying on a mountain. There we go. We look around us and we see these deep trenches, tons more craters flying around. And we fly up and off this moon. This is just one crater of the millions and millions that you can see all across the surface of our moon. So let's take a look at another picture that I captured. This one was actually, I wasn't even aiming for this. This is called the Cigar Galaxy. And what a great name for it, right? It does kind of look like a cigar, but it is another distant galaxy with its own stars and its own gas and dust, black holes, maybe even life. And this was a single image. Oh, hello, we have another person in chat. Cacillian or Sicilian, maybe? Hi, how are you? Thanks for tuning in. We're going to look at some really fun stuff. We've been talking about the moon a little bit. And I just wanted to show you this galaxy that I managed to snap a picture of this past weekend, called the Cigar Galaxy because of how it looks. It was actually a complete accident that I found it and ended up taking a picture. So let's take a look at it in Space Engine. We have the moon here, but we're going to look at the cigar. Will it call? I won't call it the Cigar Galaxy. So you know what? I actually have to look up what the designation is. So let's look up the Cigar Galaxy and see. I think it's a Messier. Oh yeah, Messier number 82. So we can go M82, and we're just going to focus on it. So it is here in the sky. You can't see it because, you know, when we're on Earth, galaxies are really far away. It's often hard to see a lot of them because they're just so dim and so distant. So let's zoom in a little bit. Woo, not so fast maybe. But there you go. This other one in the sky, we're going to talk about this guy pretty soon because that was the one I was trying to image. But right next to it is this, and this is the Cigar Galaxy. And we call it the Cigar Galaxy because it has that kind of cigar shape, but one of the interesting things about it is that, as you can kind of see, it's edge on. So galaxies, like this other one in the image, this one, well, they're all, spiral galaxies are all flat frisbee shapes, right? And so this galaxy is kind of pointed toward us, so we can see the lovely spiral arms. But this other one, the Cigar Galaxy, the one that I captured here in this picture, is on its edge. And so we're actually going to go to the Cigar Galaxy. We're going to just reset our zoom. We're going to zoom out pretty quick, so whoop, warning there. But let's go fly to the Cigar Galaxy. And one of the things you're going to realize is that as we start to fly faster and faster and faster, hey, we're up to 4 viewers. I think that's a record for a Twitch stream here. So if you're in and watching, please say hello and let me know if there's anything in the universe that you want to go and visit. We're flying right now toward this object called the Cigar Galaxy. This is a real picture, by the way, that was captured just this weekend. And we're going to fly all the way through space, faster and faster. We have to actually leave our own Milky Way galaxy in order to get to this distant other galaxy. You can just see the fuzzy patch in the center, and that's not even the place that we're going. I just want to make sure we're centered on it. Alright, we got to go pretty fast in order to get there. We're still... Whoop, there we go. So now as we leave our galaxy, we can see all these other galaxies in the sky. This is not what human eyes would see. Unfortunately, all these galaxies are very dim, and Space Engine, this software, has a little bit of help. It gives us a bit of help in seeing all these distant objects. So there's another galaxy, but this is the Cigar Galaxy that we're coming up on. And we still see it edge on from our view from Earth. It's also a really cool looking place. I didn't tell you that. It's got this big clump of gas flying off of it. It's kind of hard to see in the image that I took, but there you go. Let me just spin around a little bit because I want to actually see if I can get the angles to line up so we can compare this picture, or the picture I took, to this actual galaxy. There we go. So there you go. I would say that's pretty close. It looks good. Of course, the real thing looks a lot better than the picture that I took. However, maybe you think that the real thing is the picture that I took, because it kind of is. But this is what we got. We're actually going to fly and take a closer look at it. So let's... there we go. Now this galaxy is really interesting. It actually... the reason it had... Whoa. What do we do there? Center back on it. I think it's because we were still following the moon, so... There it is, okay. So we have to try and follow it. There we go, that's a bit better. Okay, so you can see that when we see it from Earth, we see this kind of flat shape. Because it's edge on, but it is a galaxy, a spiral galaxy, just like any other. And the reason it's got this big kind of clump of gas and dust kind of flying out of it is that very likely, in its recent history, it probably collided with another galaxy. And the cool thing is we can fly right into it. I'm actually going to fly into some of this gas and dust that's up here, because it likely has stars as well. This is generally called a starburst galaxy, or SB, I don't know, maybe not. Maybe not a starburst galaxy. I think we would have seen it, but as we fly into all this gas and dust, it's this big reddish clump of gas. And I'm not even showing it to you. Look at that. I was just showing you the galaxy picture. See, I think I do this at least once per stream, where I'm like, oh, hey, I'm talking about this thing that I'm showing you, and then I'm totally just on the other screen. So, hey, okay, this is what we're actually going to do. We're going to fly in and take a look at this red gas from this galaxy that likely interacted with something not that long ago. Oh, okay. Yeah, so this galaxy, called the Cigar Galaxy, I'm just looking at some data on it. It is really remarkable because it is what we would call a starburst galaxy. And I'm going to show you the webpage I'm checking out right now. This is another picture of the same galaxy. So you can kind of see those big red streaks. So it's very... Oh, okay, so it was experiencing some gravitational interaction with its neighbor, Messier 81, which is Bode's galaxy. Which we're going to look at again. I also tried to take a picture of that one. And so it's got a lot of extra dust and gas. It's forming really bright stars really, really quickly. And we can fly right into the core of it here. Or rather into the plane of the galaxy. Imagine living inside this other galaxy. Well, you know what? I got to turn some things on. I actually turned off... You know what I had is I turned off all procedural stars, so it wasn't actually putting any stars in the galaxy, but we're going to turn on procedural things. By the way, procedural things are things in Space Engine that aren't actually known to exist. So this galaxy is known to exist, but we haven't been able to see any individual stars within the galaxy. Okay? But I digress. This is a starburst galaxy. It's forming a lot of stars really, really quickly. And let's go and visit one of the stars in this galaxy. There's a nice blue one right there. So this is, again, not a real star, but this cool thing about Space Engine is that it produces all of these stars when we travel around. So we can fly anywhere in the universe and the stars will be there for us to look at. Imagine living in a cigar. That's a really great point. All right, so I flew right by that star. So let's just go to it, and we'll go pretty quick and see what it would look like if we were on a planet orbiting this star. This is a blue main sequence star. So main sequence being like our sun, it is a lot heavier than the sun though. 13 times the mass of the sun, as we can see up in the left-hand corner. It has 7 planets though, so let's take a look at its planets and see if we find a good one. Here's one that's mini Neptune, warm, arid Earth, so 100 degrees Celsius Earth, so pretty hot. And that thing has 2 moons, well, asteroid moons. So let's go to this planet that is orbiting that big blue star that we just looked at. We're going to travel there. We're going to land on this planet and see... Oh, that's a cool looking one. It's called a warm, arid Earth. So we're going to follow it. There we go. So that's a crazy looking planet. And look at this. This is the galaxy from that. So we're actually going to go, I think, to the nighttime side of this planet. We're going to land on it and see what it looks like from the surface. What would it be like living on this planet, which is about 100 degrees Celsius? Really hot planet, although not too bad. You'd need a spacesuit, and it would be a little bit toasty. I'm going to turn off the clouds because they're kind of in the way. But look at that. Oh, there's a nice little mountain over here. This is cool looking. Okay. Let's slow down a little bit. Let's go land. This appears to be some sort of volcano, and nothing bad could ever happen from landing on the top of a volcano, right? On a planet in another galaxy. All right, here we go. We're just going to land very gently. There we go. So look at that. There's the galaxy in the background. Imagine that you lived on this planet and you look up and there's the star, the big bright blue hot star boiling away on one side, and over on the other side of the sky you see the red glow from this galaxy. Right, you see those big glowing filaments of gas, and you see the dust lanes in the core and the edge of the galaxy. There's no oxygen in this atmosphere from the looks of it. It looks like nitrogen, C2H2, which is ethene, I guess. It's got water in the atmosphere. Very low pressure though, low gravity. Kind of a cool looking place though. This little atmospheric planet, no life. It's got 2 moons that are basically just asteroids. So let's fly back into space. So that's a planet orbiting a star. There's the 2 moons. Orbiting a star that is above the core of this galaxy called the Cigar Galaxy. So let's take a look. There goes the planet. There's the star. Blue main sequence star. And as we fly back around, go a little faster, we fly right out of the galaxy. And that's the Cigar Galaxy. And kind of what it looks like. Now I'm actually going to go and show you one more photo. Maybe a couple more, but we'll start with one more. I'm just going to pause to get a quick drink of water while I queue up the image. This is the picture that I think I'm the most proud of, even though it is very grainy and very noisy. This is called Bode's Galaxy, which is Messier number 80. This is a galaxy that is very close to the Big Dipper and very close to the Cigar Galaxy, the one we were just talking about. Bode's Galaxy is really nice. It's really big. It's got these beautiful spiral arms, as you can see. And this picture took, even in the dark sky site that I was working from this past weekend, this is only 15 minutes of exposure time. So I think it was like 10 I think it was 10 images. Each was like a minute and a half. And then you stack them on top of one another, and you end up with this really cool looking galaxy that you can start to see the spiral arms of and some structure to. But this was really noisy because I didn't get a lot of exposure time. I would have needed quite a bit more before it would have shown up really nicely. Okay, so let's go and take a look at this galaxy in Space Engine. Messier number 80, which is Bode's galaxy. So M80. Oh no, that can't be right. It must be M81. Let me just verify it. I'll just look it up in the browser. Yeah, Messier 81 is Bode's galaxy, and I want to show you my favorite picture of Bode's galaxy. So let me compare it to mine. Here's a much nicer photo taken by the Hubble Space Telescope. So that's the same galaxy that we were just looking at. Hubble and my picture. I think mine's better, but I am probably a little bit biased. Just a bit. Look, Hubble's going to take nicer photos. It's a bigger telescope in space, so I think it's going to do a better job. But let's go and actually visit M80, Messier number 80. By the way, if you're curious, Messier, the Messier catalog is a group of 110 objects in the night sky that are generally pretty bright or easy to see. Usually things that you can see with a small or medium-sized telescope, like the one that I have. So everything that you know and love, the Orion Nebula, the Andromeda Galaxy, the Pleiades, all these star clusters and things are all Messier objects because they're the brightest things that you can see in the sky. And there are 110 of them, although there probably should be a lot more than that, because there's quite a few things you can see, even with a small telescope. So let's center on Bode's galaxy. Oh no, cluster. Was it M81? Yeah, it's not M80, it's M81, which is the galaxy. Okay, center on Bode's galaxy. Okay, so very close to the Cigar Galaxy is Bode's. It's quite a bit bigger, as you can see. There's another galaxy down there, but this is, we're not actually following it, which is kind of a pain. There we go. So this is Bode's galaxy, the one we were seeing in my image, and I'm going to try and get the same angle that we had to try and get, there we go. So there's my image. I think I'm kind of upside down on it though, because the spiral arms are the wrong way. So I'm gonna spin it around. Let's try it. Try it again. So again, another galaxy in the sky. One of the things I love about imaging galaxies is that they're really difficult. They're so far away. They're so dim. They're just, I mean, they're made of billions upon billions of stars, but yet they're still not bright enough to see without a really powerful telescope and a lot of exposure time. I think that's a bit better. There we go. So now we can compare that. Whoop, too close. I gummed it up. I just want to go slow, okay? Just nice and slow. There we go. So there you go. There's my image, excuse me, of Bode's galaxy, Messier number 81. And that's the actual galaxy. So this thing up here is a small galaxy that's orbiting Bode's. You can kind of see it moves pretty close. Bode's galaxy actually was pulling on the Cigar Galaxy, and that's why the Cigar was forming lots of stars. And you kind of get the same view when you look at Bode's, especially when you look at this Hubble image. You can see a lot of the spiral arms are where there's a lot of bright regions where stars are forming. Oh, Jen says, Lucas said galaxy for the first time. Well done, Lucas. I'm very impressed. I wish you recorded it as well, but that's all right. I can only imagine him jumping up and down saying moon. I think you've shown me that before, but if you do get him saying galaxy, I'll just keep saying galaxy so he keeps saying it too. We have a budding astronomer in that young guy. So this is Bode's galaxy again. Lots of star forming happening in there. We're going to go in a little bit closer and just explore it. And so you see now it kind of looks a little bit more like our Milky Way when you look at it edge on, because we're inside the galaxy now. So we fly on through. Clumps of gas and dust fly past us. All right, we're coming up to about 10 minutes to 8. Is there anything else that we want to take a look at? I'm going to probably go back and take a look at something else in our galaxy. Just go and visit the Milky Way, where we're from and where we live, and look at a star, something in the Milky Way. So let's fly on home. But if there's anything that you want to look at, any particular planet, galaxy, star. Actually, you know what? Oh, can we cruise by Europa? That's a great idea. Let's go cruise by Europa. Let's go back to the Milky Way. That is exactly how you spell Europa. E-U-R-O-P-A. It's Europe with an A instead of an E, which is kind of nice. You can kind of see Europa, moon of Jupiter. There's also an asteroid called Europa as well, which just to confuse things a little bit, right? All right, let's take a nice slow flight over to Europa, which is in our solar system. So we're going to see that the sun is about 2/3 of the way out from the center of the Milky Way galaxy in a spiral arm that we call Sagittarius. So we're going to fly in. It's going to happen pretty quick. We're going to get really close to the sun really fast. And to the moon of Jupiter. There we go. Whoop. That was pretty quick. So this is Europa. We are following Europa, which is nice. Europa is a big ball of ice, which is kind of neat. It is a moon of Jupiter, so if we fly around long enough, we should be able to see Jupiter. And I'd be willing to bet that it's down here. There it is. And the reason I know that is because you can kind of see the light, the reflected light from Jupiter shining on Europa over on the left side. The right side has the light from the sun. And so you can kind of figure out that Jupiter is down there, which is kind of a cool view. So I'm going to get a nice screenshot of that. There we go. Now, Europa is a big ball of ice, which is kind of neat. Underneath that ice is likely liquid water. Because Jupiter is so big, it has so much gravity and so much of what we call angular momentum, it tugs on Europa. And the other moons of Jupiter, the big moons, the Galilean moons, Io and Ganymede and Callisto, they also pull on Europa. And that push and pull from the moons and from Jupiter causes the crust of this moon to shrink and grow, expand and contract. And that generates a huge amount of friction and, sure enough, a huge amount of heat. And that heats up the core of this moon and melts all the ice. So under about 40 kilometers of ice on Europa is a liquid water ocean. Now this, in my opinion, is the best place in the solar system to look for life, because in that ocean you have basically all the things that are needed for life, as far as we know. As far as we know, you need water, which there's a lot of, and you need a heat source, which there is. And so maybe down deep underneath this ice, underneath these cracked icy surfaces that we can see here, these big beautiful spines of ice, underneath this there's an ocean, and in that ocean there might be little bacteria. Maybe there's even fish or some kind of giant whale that we had no idea ever existed. It could be a place with life. And we can go in closer and closer and see just these cracks of ice. This is a real image, based on real images of Europa, by the way. And so it's limited to a certain resolution. They were likely taken by the Galileo spacecraft, which was in the early 2000s, I believe, that went by Jupiter. Currently, there's a spacecraft called Juno that's flying around Jupiter, taking pictures and flying in to the planet really, really close. There it is. So that is Europa. I'm really excited that hopefully in the next decade, NASA is going to send a spacecraft called the Europa Clipper to go and fly past Europa, drop a little spacecraft or a lander, maybe a little drill or a submarine or something that can drill down through the ice into that ocean and sample everything it possibly can to see if there's life down there. So I'm hopeful that in the next 20 years, we'll have some sort of evidence of whether or not there is life in places in our solar system other than Earth. Lucas should start prepping. I think he's the perfect age to be one of those first people on Mars. I don't know if it's going to happen for a little bit of time, but, well, he's got a lot of preparation, and you're helping him out really nicely. All right, let's go visit. There's one other place I want to go to, and that's a star called Albireo. It's one of my favorite things to look at. You can look at it in binoculars, a small telescope. It looks really nice. It's actually what we call a double star. So it's actually two stars that are orbiting each other. And if we zoom in, this is kind of what it looks like through a telescope. We see one star, and look, all of a sudden, as we get close enough, we can see that are two stars. And the beautiful thing about this double star is that one of them is red and one of them is blue. It's actually a triple. Who knew? There you go. So there's actually a third star that orbits with the other two, and I bet it's this guy right here. Is that part of the system? It won't let me click it. Okay. Anyway, so we have two stars, a blue one and a red one, and it's very easy to see the colors of these stars when you look through a telescope. And I'll see if actually, I'm going to try and pull up a photo of that, because I just organized all my space photos in an album. So I did take it. I captured the photo of Albireo just last year. So I'm going to pull it up. Yeah, here we go. So this is the real photo. That's a real picture of that double star, the red one and the blue one, through a telescope. And actually, I think that's through my big telescope, so they are very close together, so maybe you won't be able to see them in binoculars, but still very easy to tell that there's a red one and a blue one. Now, I don't know if there are planets around those stars in real life, but we're going to go visit them. There it is. So let's go fly there pretty quickly and see if there are planets. And we'll be able to tell if they're real. I don't think there are planets. It's actually a lot less common to find planets around double stars. There we go. We're at the core of the star system. So if we zoom out a little bit, there they are, the two of them. So let's see if they do have planets. Oops, wrong one. Wow, okay, so the red star is big. It's it's a really big star. 8 solar masses probably. And the third, oh, interesting. Okay. So here's something neat. Let's go take a look at the chart. So look at this. The red star. Okay, so the red star and this third star, Albireo C, actually orbit one another. And then these two actually orbit a central point between them and this other star, the blue main sequence star there. So it doesn't look like there's any planets around this double star, but look at the size difference in these two. Like Albireo A, 5 times the mass of the sun, really, really big. Albireo B, blue main sequence star, still 3 times as heavy as the sun, but not as big, right? Much smaller, so it's much hotter and more blue. And the third star is still pretty big as well, another B-type star. So B stars, O and B stars tend to be the hottest, and not always the most massive, but generally the hottest. And so these are both B-type stars around 3 solar masses, but no planets, unfortunately, which is a little disappointing. Oh, no, I hit the wrong button. So let's go visit a nearby star. What's a good star to visit? You know, let's go to Vega. I think we did that recently, but Vega is one of my favorite stars, so let's go to Vega and see if it has planets. And see, I don't know if Vega really has planets, but in Space Engine, it might have procedurally generated planets. So there's Vega. Vega is twice the mass of the sun. And one of the cool things about Vega, I think I've shown this before, is that Vega is an oval. It's football shaped because it's one of the it's one of the fastest spinning stars that we know of. So this star is spinning so quickly. Like if I let time go forward and speed it up a little bit, you can actually see it spinning. This star's spinning so quickly. Like we're going at about every second for you and I is about 1 hour of time. So this star, as big as it is, how big is it? Let's see, where is it? Size, apparent size? No. Diameter, okay. 2.5 times the diameter of the sun, and it's spinning in like an hour or 2 hours, which is crazy, crazy fast. The sun, which is half the size of this, spins in about 30 days once. So this thing is just cooking. It's going really fast. Does it have planets? Oh, wrong one. No, it doesn't look like it has planets. Or did I just leave all the planets off? No, I left procedural planets on. So, yeah, no planets on Vega either. All right, let's try. Okay, there's one that I know has a planet, a real planet. Fomalhaut. What a great name. So let's go to Fomalhaut. It actually does have a real life planet. We're going to go visit that, and that's probably the last thing we're going to do because we're coming up to 8 o'clock. I'd like to thank everybody for checking out the stream. It's been a lot of fun. One thing you're going to notice later tonight, I'm going to try and finish up this video on the Mars 2020 mission that launched today. I've been working on it all day, so I'm looking forward to actually getting it out. So this is Fomalhaut, a white main sequence star. I believe it's in the southern hemisphere. Alpha PSA Piscis? I don't know. Piscis Australis. Yeah, that's a southern hemisphere constellation. But it does have a real planet. It's been named, apparently. Dagon. Cool. Now we'll go to the planet. We don't know what it actually looks like. It has been directly imaged, so we do have a lot of information about it. We know it's a big planet, a super Jupiter. So it's 13 times the diameter of the Earth. And this planet is probably, well, it's pretty cold, minus 236 degrees Celsius. Because it's similar to Jupiter, it has an atmosphere made entirely of hydrogen and helium. It's pretty heavy, 3 times the mass of Jupiter. And how close is it to its star? Oh, not very far at all. 343,000 kilometers from its star. Well, far enough, I guess, to be pretty cold. And there you go. And this is a real planet. We don't know that it actually looks like this. It might not. But this is it. Let's track it so we can fly around a little bit. So yeah, this is a real planet. And this is one of the first, you can see it's discovered in 2008 through direct imaging. This is one of the first planets that was directly imaged by a telescope. And that's because Fomalhaut is not super far from Earth. If we look at it, distance 298 astronomical units. Yeah, that's pretty close. That doesn't seem right. Maybe that's our distance from the star right now. I don't know. Anyway, this is a real planet. Kind of cool. So let's finish up. Let's fly back to Earth. We're going to take a nice long flight to the Earth. Let's untrack that. So Earth is over there somewhere, but let's go nice and slow. We'll take the 30-second flight back to Earth. And then we'll finish up because we're just at an hour. So I want to say thanks a lot for joining me tonight. I hope we got to look at some really cool stuff. I thought it was a lot of fun. I had a blast. And even though my voice is really suffering from recording videos all day, I'm still really pumped to be able to talk to you lovely people. So thanks for hanging out. It's always a pleasure. And I'm going to keep doing it every week as long as I'm not doing live planetarium shows. Because it's fun. I hope everybody stays safe and healthy, and that we'll talk again soon. I'll bring up the main image, and I'll say good night. Talk to you again soon.